So the idea is that shortcodes, for shortcodes, I made a parser manually, a handwritten parser. And what I did is that I extracted the parser itself to make it reusable because it was fast and beautiful. So I'm like, yeah, let's reuse this shortcode thing and make it a project. So now it's using Parlot. So if I look at the PR, you will see the PR is very easy to understand. Before this PR, you see we had the character, the cursor classes, and now they are not there anymore. They're in a package. And the scanner is also gone. And the code is almost the same. So just typo here. The code is almost the same, just that the class name changed. So now we have a shortcodes parser that is using Parlot, which is a new package that contains what was in shortcode. I wrote the grammar of shortcodes. So shortcode, well, a text is based on shortcode and text nodes. So shortcode, text, then shortcode, then text, then shortcode, then text, and so on. The shortcode can have an identifier and arguments. Well, it has an identifier and needs arguments between brackets. And then you have a closing shortcode. An argument is identifier equals value. It's actually also just a value, if you want. And a value is either a string or a number, so integer or decimal. That's all it can be. Then this code, which is the same as before, almost just from the library, you can see here is just a bunch of first level methods like parse node, parse text, parse integer, parse string, something like that. And it's just aggregated just to follow the grammar and to build a syntax tree of the thing. So that's all it is. But now it's a new library. And next week, I'll show you how I use the new library in the other packages that we use in Orchard to make things faster, because it's faster than the ones we're using for Fluid, for instance. I'll show you later. So shortcodes is faster now. We can update it, and next week Fluid will be faster also. It's already, but I'll show you next week.
So Hicham started a PR.
You're good. Sorry.
Yes and yes. What? Hicham started a PR. Yes, so that's why Hicham started. So it's funny because when I published the package, when I created the repository, I didn't tweet about it or blog or whatever. I just created the repository, and I started seeing likes, and I'm like a few minutes after.
Yeah, I didn't know what it was at all, and I searched and I found it.
Yeah, and I pinged like Laurent because I know this guy, and I'm like, how do you know about this repository? And he says because he follows me, and when you follow someone, you get a notification when they create a repository. That's how they got that. So Hicham also found it, and Hicham, by seeing it, understood what it was, and he was like, okay, I will do the same thing as you did for shortcode using Parlot for Fluid, because Fluid is also using Irony and is parsing the liquid templates. And he started, so, and when he said that on Fluid, on Fluid, he created an issue to do that, okay? And I said, instead of doing that, which is complex, try first, if you want, with the SQL grammar in Orchard Core, because the SQL grammar is also a parser to parse SQL, and it's Irony, and it will benefit from the perf of Parlot, and it's much easier to do. So that's why he started the PR to use that, because there was a package. There is a package for that. I need to update it. There are lots of newer features there. Yeah, and since shortcodes, there are new features. So like this is the code from shortcode. Okay, well, this is just to parse an expression. So you read the char, you read stuff, read numbers, very low level tokens. But there is also a Fluent API to build parser, something like unary and star mapping, which is 0 or more, or which is that thing times. So you just write stuff like this, and inside it will use the low level API. So you have the choice to use the high level or to use the low level. And you have a perf cost for that, but even with that, it's still faster than anything you can find in terms of parser. So Sprasher Superpower is like Irony, the one we are using. Pidgin is one created by Stack Overflow, and this is Parlot. doing the same thing. So this is parsing JSON documents in this case, but you see 10 times faster than something like Sprasher, which is famous. Pidgin has been created to be faster than Sprasher, and Parlot now is faster than Pidgin for every cases in this case, and even in allocations. Look at that allocations, they are equal because it's just allocating JSON. Well, in this case, it's faster, but compared to parsers like Arony, Sprasher, it's much faster. Same thing here, just comparing the low level, the Fluent API and Pidgin. Even the Fluent API is 5 times faster than Pidgin. Same thing for these big expressions, and these are just mathematical expressions that I'm parsing in this case. And in terms of allocation, it's a little bit better than Pidgin. So it's less allocations, it's faster. So that's why we should see some, well, we see some gains in shortcodes, definitely. I think it's ×2, something like that. And I can see also changes in Fluid. Fluid also, it takes half the time to parse and 10 times smaller allocations. And it's not yet the fastest, because if we migrate the Fluid grammar that I made to the raw, we should be able to get, let's say, 3 times faster again, and even less allocations. And the conversion is very easy, because the Fluent API is just a mapping direct to the low-level API, which is not that low level. So that's super nice. Just to show you what it looks like, there is a PR and the grammar for Fluid, which is not super easy, but because I worked on Parlot, it was much easier for me to write. What is that? How it looks like for Liquid. So you can find, let me show you an example. A range, for instance, is when you type something like 1.3, or it can be also foo.5, okay? And that's what it says. So it says left parentheses, and then one of an integer or a member, then the text ... then an integer or a member, this one, then the right parentheses. And when you match that, you return a range expression with the first element, which is an expression, and the second element, which is an expression. When it finds the first one, it says, if it's an integer, it returns an expression already. If it's a member, you create an you map the member expression to the type expression, to the base type. So they have both the same type. So this thing returns the same type, and so on. So that's how it works. So it's super easy to create the parser, and it's still super fast. Can be faster, but super. And this full code here, this file, it's not trivial, but compared to what we had before we had that file ×2 plus another file that contained all the logic to find the beginning and the end of each tag, and the recursivity, which we have now here directly in the nodes. So it's much easier to maintain, actually. And what's good is that I assume this is the one I fixed this morning, the last one, if it works. Everything is green. So all the unit tests in Fluid pass now. Well, now they passed before the change, but even with this change, everything is passing. So that's great. That's what I did during my holiday break. Just did that. So fun. Good. That was my demo. Nothing to do with Orchard Core directly, just indirectly, which is still good because it will make the Liquid parsing faster. Shortcodes are already faster. Now Liquid will be even faster. We can use Liquid everywhere now. We can replace Razor. I need to no, the rendering is exactly the same because it's the same AST. There is no change in rendering Liquid. So once the file is cached, there is absolutely no gain. The only gain we have here is when we use, for instance, a live preview, because whenever we type a letter, we have a new parsing that happens. Okay. That's it. Questions, comments?
Awesome.
Just having fun.
Yeah, but I mean, you work on performance with the ASP.NET team, so that helps. Yeah, that helps a lot for us. Yeah.
Yeah, but yeah, the goal was to make something faster, because when I evaluated the cost of parsing fluid compared to other fluid parser. It was fast, but not as fast as the fastest. And I wanted to understand what was there. So last year when I benchmarked Sprasher, Superpower, and Irony, I realized that they all had the same cost of allocations. So whenever you go with a Fluent API like this, you had to pay for that. But I will not rewrite everything in low-level parser generator. So when I did shortcodes, I did a semi-low level, and that was very fast for what we wanted, and that was good. So I was like, maybe I could extract it as a library. So I started to extract, and then I was like, then where is the Fluent API losing so much? And I tried, and then I saw that it was not that slow. And then I thought, well, it's super fast, but I found Pidgin. And when I found Pidgin, I was like, well, I can just throw everything away because Pidgin is exactly what I want. Pidgin is a parser combinator library that is super nice API. And the goal for when they made that was for perf. So the numbers they show was like, yeah, that's great. That's much better than Sprasher and Superpower. So I tried to do a minimalistic Fluent API with Parlot and to compare with Pidgin, and it was still faster than Pidgin. So I continued on that. And now it's still super fast compared to Pidgin.
And Pidgin is done with what language? Is it done in C++ or C#?
Yeah. Oh. So what I'm talking here is just C# solutions. Okay, I'm not talking about C++ solution, whatever, because we want to run in C#. However, if you take tools like Untitled, which is the most famous parser generator, Untitled can generate as many languages as you want. There are some C# bindings, and by the way, the person responsible for the C# binding is working in the .NET team. I've used Untitled since like 2000 single digit, like 2004, 5, something like that. So I know that very well. I've done so many languages with that. The first version of Gint was using that, I think. And I've done, it's so funny, it's out of topic, but look at that. If I go in the Irony project, which is the one I was using in free, I'm still using in free, okay? Or the one we are using in SQL Grammar. Yeah. It's so funny. You see this guy here, Alexei Yakolev. He's the maintainer now. Well, the original creator of Irony works at Microsoft, but Alexei here worked on Sprasher and now contributes to Irony and then contributed to Sprasher, something like that, I think. And if I looked at his profile, and I saw some, you see, he built the mathematical expression for Sprasher, which is another parser generator in .NET made by the guy who made AutoFac. So if you look at this repository that he made, I look at the README, and it's an expression, a mathematical expression evaluator. And when you read the thing, it says, can be easily compiled and executable. It contrasts with interpreted expression evaluators such as NCalc. I made NCalc. So it's funny how the loop creates. You don't know NCalc. I know it because I made it like 15 years ago. And you talk. So if it's so someone, I won't say stole it. Okay. You see evaluant here. Maybe here, Bertrand, you know what evaluant is, right? Let's see if you are still there.
Yeah. Yeah.
Okay.
Of course.
What is it? just to be sure. I didn't say anything, right?
That was your company in France.
Yeah. So that's the company I made. I created in 2001. Okay. Before I joined Microsoft. So that just proves you that it's my code. And by the way, I'm sure maybe the license says that. Let me check. Yeah, it says it. Okay. So I didn't say it. So it used to be on Codeplex, and someone before the code gets lost. Yeah, I see. And actually that's him. Well, before the code gets lost, it's interesting. I didn't know it was him. I just saw the mention. I didn't click on the repository. They copy pasted the code and they created a GitHub repository for that. And what it does is, and you will see the relationship between all the things I do in Orchard and Gint and shortcodes and everything. You type something like 2 + 3 × 5 expression, it's evaluate, and it gives you the results. Okay, it's interpreted the thing, but it's not just math. You can pass dates, you can pass functions, you can add your own functions. So it's like a micro language. Okay, but just for mathematical expressions and variables and things like this. And this was before I made Gint. After that, I made Gint, which is a real scripting engine, but this one is not. There are ifs and else and things like that, but you can't do loops and things like that. So that's why I made after that Gint. And you see around the time 2011, this was the last version they made, but I started in Gint with a colleague in France around 2009, 10, something like that, 2008, I'd say. So yeah, so just saying that, what was I saying? Yeah, Untitled is also a way to generate code, but Untitled generates the code. Once it's generated, you have to compile it and add zone. The nice thing with parser combinator like Sprasher or Pidgin is that it's all from C# dynamically in the language. So you can alter it dynamically. You can change the grammar dynamically. That's super useful for Fluid because we can add custom tags with custom expressions, custom blocks dynamically. And we do that in Orchard. We add custom tags. We add custom expressions to provide features.
And it needs to be on runtime. Yeah.
Yes. And Pidgin then is another one that works on C#. I discovered just by reading documentation about the parser generator. So example, and you will see the code is kind of similar to Sprasher using link expression and everything, but they have this digit, parse, or throw, well, digit, when they have strings, the same thing as the low level in Parlot. And everything here is a parser. That's how parser combinator works. This one is a parser, but you have the then, which takes a parser and returns another parser. Okay, so that's how it works. And then they have benchmarks numbers comparing to a F# solution for expression, mathematical expression. So when I saw that, I'm like, okay, I did the expression benchmark on my side with Pidgin. Okay, and I know that I'm faster. And then I saw the JSON bench, and it was a good example. So I did the same grammar because it's a simple, JSON is simple. And what I liked here is that I had already the numbers for Sprasher, Superpower, and fparsec, which is in F#. And you can see that it's a little bit faster than fparsec. It's much faster than Sprasher. So when I saw the numbers, I'm like, Pidgin is great because this is exactly where I wanted to go. I wanted, because these numbers, I knew with Fluid that they were the same as Irony. So I'm like, if we can get these numbers, it's great. And also the allocations. If you look at the allocations, 5 megabytes, 100K, 1 megabyte, 100K. Okay, that's huge. The difference is huge here. And that's really why we need a new parser. But now I know that Parlot is even faster than that. Okay, so that's interesting.
It was like twice faster?
For the JSON, it was 4 times faster. And then this is just the Fluent level. So this is apples to apples, okay, the Fluent API. Something like you write the grammar like this, okay, like this. Fluent API. Apples to apples, it's 3 or 4 times faster. And then there is the low-level API, which I use in shortcodes, and that is very easily convertible from the Fluent API to the low-level API. And it's even much faster. So if we want to go the next level, we can convert this thing to the low-level API. And it's super easy because whenever you see char plus, you change the code by if scanner.readChar. Then, and then you have that. If parse rec, which itself will parse. So it's, I mean, just elementary blocks that you have to write the code for instead of wrapping them in a class that has more allocations and passes parameters around and copy values to be less dynamicity. But that's good. So ideally,
more strict code.
Yeah, and ideally, what can be done, and that may be something I will do, is you see this code here, 0, 1, and skip, separating. So separating is just give me a separator, and what should I like? What should I read? So this code, it returns an object graph of parser. So this returns a new object of type 0, 1. This returns a new object of type sequence, 1, 2, 3, 4. So these guys, instead of parsing the thing, they could just generate code, like generate the code that does the for loop, generate the code that does the if end, Okay, generate the code that takes the code and writes it down. And so instead of evaluating it, it could also have a different visitor, which is generate me the code at the low level. So it will serialize the logic by code, which is what Untitled does. So it could also do it dynamically, because we could generate the C# code from C# and just generate the assembly that contains the code like Untitled would have generated. So it's still dynamic because you can reconfigure it. But when you want to freeze the configuration, you can say, now, give me the parser by generating the code for the parser in an optimized way. And then you have the Fluent API that you can test, and it's easily debuggable. And when it works, you can say, okay, now give me the optimal code, build it, compile it. So that's what a regular expression does. In regular expression, you can interpret the regular expression every time, or you can say compile, which will generate the code that is actually doing by interpreting, but generating it a one-off in an optimized way. And this way you get better, faster performance on a regular expression. So that's the same logic. And these guys are small ones. They are super easy to understand. But that's what a 0 or 1 does. It just takes a parser and say, does it match? No? Well, whatever. I match something, even if it match 1 or not, because it's a 0 or 1. You see that all these things are just simple implementation. So here in this case, instead of executing this method, you will just forward for the sub1 to say, write your code. And if the sub1 is just read integer, then it will just read integer. But so that's why I think it's simple to go to the level of the lower level. See the star, for instance, 0 many, super simple. 0 many, it tries to parse, and if it doesn't, it says, no, that's still fine because 0 works. But the 1 or many, I have a 1 or many. I have a 1 or many. 1 or many says parse once. If it doesn't work, you failed. If it works, then you can read as many as you want, and then you succeeded. So that's how it works. That's super easy to implement actually when you get the logic, and you just need to provide lots of little helpers like this. So or you will be allowed to cut everything I said during the meeting because it's kind of not related.
Well, I think it's good because people that wants to develop with Archer now have some explanation of what is Parlot, and I think it's fine.
Yeah, so that's why Isham started his PR to convert the SQL grammar into that we use using irony into Parlot.
Yeah, now I understand better. Yeah,
and it should not be that hard because this is the same Bacchus no kind of grammar, and I actually find the Parlot one much easier to read than the irony one. Because you can read it this way, and you don't have in irony you have to split that in multiple different things that will call into each other. Here the notion of recursivity is already there, and that's what is nice with these tags, because if I take, for instance, a comment tag is comment and comment contains lots of tags. Okay, it's just not parsed. So how it works here, you say just comment. Well, that's not a good example. If I take the if tag, okay, takes a tags list. So I can put the tags list inside my tag. And the way it won't find the endif as a tag is that there is nothing for endif in the list. So when it finds endif, it says, it's not a tag. So it stops reading the tags list and it continues there. And it says, oh, now I know that I want to tag an endif. So this recursivity is super nice. And in irony, it's super hard to make. And the fact that you can also express directly the AST you want in C# when you find a node. Like when I find else and then a tags list, I say the result of this thing is an else statement. And the property of the else element is the list of statement, which is actually the tags list. The tags list is a list of statements. And so this is a statement, this is a statement, and when everything is read from an if, it returns an if statement with the item 1, which is the tags list, item 2, which is this one, item 3, and so on. Okay, so this is using tuple. Super useful also. So that's super readable actually when you want to look at it and implement it or change the thing. Here or many one of, like in the for loop, you can have limits value, offset value, reverse value in any order. So the way I did that is that I did one of these three, 0 or many. So you can have many other. And in the end, I think I take the first one or the last one, whatever is defined. So if you have two limits, I take the last one. C# code, super nice, integrated into the parser. That's it. Okay, good, done. Beautiful. Thank you.
Yeah, I was looking at the SQL parser and SQL grammar classes, and I kind of understand what needs to be done there.
Super interesting to learn. I mean, we are all developers, so we want to solve puzzles and to teach machines to read stuff and to do things. So that's something that's super interesting to try to do. Like, you saw my story. I did some manual parser, but I never did a parser that can be reused. I always used parsers, Untitled, Irony, and others. Remember?
Hey, question.
Yeah.
So there are lots of cases where we as developers, we have to quickly parse something, extract some information from text, and we go to regular expressions in lots of cases. Can you say something about the comparison with, that sort of thing, extracting content using regular expressions? How does it compare in terms of, perf and ease of use? I mean, that. Yeah,
I thought about it actually.
Use that than regular expressions any day, but how do we compare?
I had a thought about it yesterday in the opposite way, saying actually that's bad, because for the same reason as regular expressions. Because when I see regular expression in the code, I'm like, if you can not use it, don't use it, because there are lots of vectors to break your code with that. So last year I had to update or should
and it's terrible to manage as well.
Yes. Well, I've been doing regular expressions for 20 years. I still need to go on the website to write a regular expression.
Yeah. Same
like is the dollar at the end or the end? Or is it the...
Oh, come on.
Yeah, well, you see why. Just the details, like,
Yeah.
And you have tools. That's why you have so many tools like helpers on the web or locally. Like, they are super nice tools to show you what happens when you type something. And I have the same issue with the grammar. Like, now when you start...
Actually, if you had some tooling around that would be that would be pretty cool. Something like Linkpad, maybe Linkpad itself, actually.
That's why I like with Irony. They have that. In Irony, you can pass a file, and they have a WinForm tool that will show you the AST, a generic AST, with all the things it finds when you throw some text at it. That's great.
Yeah, that's awesome.
So I used it a lot.
I'm thinking you might be able to use Linkpad for that.
Probably. But yeah, so when I was building the free grammar, I had this issue, the tooling, like, it doesn't work. Where did it not work? And that's why I did see the name here. So now I can add a name to a node. So when I debug, I know which one I'm in, like the skip, and I have so many of them, I don't know. So the idea is that also what I added is, if you look at the parser, the iParser, the parser class.
So there is the maintainability part, there is the tooling part, but there is also the performance part. Recently, I tried to refactor some code that was using regular expressions to use some custom logic that I thought would be faster. And actually, regular expressions are amazingly fast.
Yeah, their structure. Yeah, I think I saw how it works in the big gray book with all the algorithms that very famous.
It's amazing. It's magic.
And I'm like, what the fuck? How did they think about it? And it's beautiful. The state tree that they have to find. I'm like, what? But yeah, probably for the simple things, it's faster to do by hand. But so what I was saying earlier is that when I say don't use a regular expression because it's risky, I actually thought that it's actually the same for parser, because with regular expression, you need to pass a timeout. If you don't do it, that's wrong, because it can time out if you pass a wrong entry. It can go into the infinite state, And actually in this parser, there is no timeout, and that's bad, because how many times did I have a Stack Overflow in my language?
Right.
It's very easy to see. Look, let me show you an example. Here, it's all in the details, but
and there might I'm thinking there's probably some security implications here.
Well, that's
true. You could use poison, right?
Yeah. So here, liquid is what? Is either it's a set of tags like this, or text. This is what it is. So if you have something like foo bar, it says, oh, is it something like this? It says no. Is it something like that? It says no. Then it's a text, and it reads, and the text reads until it finds that. Then it starts again. Is it something like this? No. Is it something like that? Yes, that's it. That's how it passes. But now if I do text before, I mean, is it a text? Yes. Okay, start again. Is it a text? No, start again. There is a case where you can have infinite loop because it doesn't work. And this case will depend on what text you pass inside. So you don't know. You might actually have grammar that will have a Stack Overflow. And I had a few of them when I was developing. And you can only find it when someone types something wrong or knows how it works and can crash your app. So when you have Stack Overflow, then you're done. You can restart your application. So the same reason for regular expression, it's super risky actually. So I was thinking, well, maybe we should not use a parser because the same reason I say don't use a regular expression. Or at least I should provide the same fallback mechanism as regular expression, like a timeout, like steps. I do that in Gin, for instance. If you have a recursivity more than 100, stop it. There is an issue in the language. And that's why the Parlot context or the parse context here, which is common to the full navigation, I started to add the enter parser. So every time you enter a new parser node, like text, output, decimal, and one many, it will invoke it if you want. So you can trace what's happening. And we can also provide some count, like counter plus plus, and if counter superior at 1000, then 1000, then throw an exception, like too complex issue. I could not resolve that. There is an issue. Stop. Safety nets. And the same way.
That sounds very necessary. Yeah.
So we need that. So and I couldn't find it.
Yeah, if you can come up with a couple of test cases that compare with regular expressions, it'd be interesting to see the performance of that.
Yeah, and there is a low level and a high level. So with the low level, I don't expect regular expression to be faster because what I did is that and that's what I took it from shortcodes. I optimized it in a way there was no allocation and using the spans, the read-only spans or the internal spans, allocating very few using ref structs, all the things you can think into C# to make code fast.
Yeah, that's pretty awesome. I'm a fan already.
Great. So and now I want to see some.
Did you say where the name came from?
I didn't say that. I think it's a good name. Every French guy who finds it says it's a good name. I think even some English one understood what it meant. So Parlot is a French pronunciation of a word. Well, it's not like you write it in French, but if you say it in French, it means like chit chat or someone who talks a lot. And it's nice because Sprache, which is, I assume, the language in German. So it's kind of the same logic, like language stuff, like analyzing syntax. I like it. And I don't know how I found it. It was kind of easy, actually. I was looking at parse something, and then
Sprache is speech, if I'm not mistaken.
What?
It means speech, if I'm not mistaken.
What?
Sprache.
Okay. Yeah, I assume. I don't know. I have to Google that, but probably. Language. Yeah. Or maybe there are different meanings for that. Just Google that says that. So, yeah. Chat. But it's written like this. In French, you will write it this way.
It's a very uncommon word. I'm wondering if actually it's it's something like a local word.
Parlot, I googled that and I could not find anything.
Yeah.
So that's great. Like, boom. See?
Yeah.
Direct.
That's pretty cool.
It's on GitHub free. But I finished it like Sunday night. Okay. I spent my so it's super new. That's why I didn't talk about it. I wanted also to have to validate that with a real grammar. Okay, if I can parse fluid, if I can parse liquid, I can parse anything, because there are some very weird things, and I made helpers on the way.
We use Parlot on my team, and
wow,
I've already advertised your library on our teams.
Okay.
On our team.
Yeah. So yeah, I mean, changing the grammar from Spraker to Parlot should be super easy. You see, I mean,
yeah,
it'll be easier.
Yeah.
And the nice thing is that it will be already much faster. Okay. And if you are on the web, the load and the locations, it will be important. And then the next level is to convert it to the raw level. It's super easy, so easy. I mean, once you have that and it works, and all you need is pass, just do translation manually. If we don't have the tool that generates it automatically yet, I mean, that's so easy. I did that for the calc mathematical expression. So these are my tests. So the calc here, I did 3 of them, actually. It's super interesting. So the fluent parser for the mathematical expression is, you see, so this one recursive because unary is using unary. This is a unary, and it uses minus unary, so it has to be recursive. And negate expression, the factor is division or multiplication, and it's just unary expression and as many times divided or times and unary. You have to read it, that's super easy. And from that's the fluent, okay, super easy, right? To write the expression. Yeah. This is ncalc. That's why the other guy used Spraker to make calc, because that's how you write it. And then this is the low level one. And the low level has 2 implementation. There is the parser, the parser one, which returns the same object model, but parse expression.
Yeah,
so if
that's not too bad.
See, that's super easy. And it's the same grammar. I show how to map it. It's actually the same thing, like parsenary, read dash, and then negate of the inner. And the inner is just parse expression. Well, parsenary expression, and so on. So very easy. And then, so this one creates an expression tree also. And then there is the interpreter version that will evaluate each node as it finds it. So there is no intermediate AST.
So what's the point of that?
There is no allocation for the AST. It's just when it finds number, it computes the number and it returns it to the caller. And the caller, if it says times, okay, let's do it now. So it doesn't create an intermediate object that will be visited after. So it's much faster. But you can't apply that to many things. For math, that's fine, but that's it.
Oh, okay.
Because when you are inside the times, you can evaluate the times and stack the value. When you are in liquid, you can't allocate a string just for the else if and then put back up, and you have lots of strings everywhere otherwise. It's not poppable. You want a stream of stuff in order to be able to write to a text stream. So you need an intermediate representation that then you can write in order. That's, yeah. It depends.
Okay, that makes sense.
Differently. But I did that as well. And the JSON grammar, I mean, it's a minimalistic JSON grammar just to match the benchmarks. That's super simple because there is a string helper that asks you, do you want the double quote, the single quote, or both? And it will do all the things for you for the string, okay? And then here, this is the expression tree. The array is left bracket, right bracket. I use the between helper, and inside I say separated anything JSON by comma. This is an array. It's like 20 chars to define an array of.
Hold on. So you have a decent I mean,
this is JSON.
I suppose it doesn't support everything, but you have a decent JSON parser in what, 100 lines of code?
100. I'm 56.
No.
Well, the grammar is 20 lines. We have to try. But yeah, there is no numbers. To add numbers here, the string, you have to do JSON number and then the primary, which is string or number or date. But that's it. And then it's done because that's all you need to add.
Okay. I'm excited.
Have to try.